Welcome to part 1 on the video on polynomial long division. First, let's start with dividing with numbers. So I'm dividing 3,587 by 32. First, I'll ask myself, how many times does 32 go into 35? It goes in once, so I write the 1 above the 5, which is the last digit I used. And then I do 1 times 32, which is 32, and write those digits underneath. Subtracting down the columns, 35 minus 32 is 3. And then I bring down the 8. Now I go back. So I'm dividing again. 38 divided by 32 is 1. 1 times 32, so that's multiplying, gives me 32, and then subtract. 38 minus 32 is 6. Bring the 7 down. 32 divided by 67, 32 goes in twice. So now I multiply 2 times 32 is 64, and then subtract again to get 3. I'm out of digits. So normally with numbers, we would keep going and get a decimal answer, but with polynomials, we won't be able to do that. Instead, what we'll do is write our remainders as fractions. So if we were dividing by 32, our remainder is a fraction of 32. So our answer is 112 and 3/32. So now let's move on and do a similar problem involving polynomials. We're dividing 3x cubed plus 5x squared plus 8x plus 7 by 3x plus 2. Now, I'm still going to divide, multiply, and subtract. But the difference is when we're dividing, we're only going to use the first terms. So here's what that means. When I divide here, I'm just going to think about 3x cubed divided by 3x. Or 3x times what amount gives me 3x cubed. That answer is x squared, so I write that over the x squared term. And now I'm on to the multiply step. Now the multiplying is going to involve both terms, the 3x and the 2. So I'm going to multiply x squared by 3x and by 2. And those become the terms that I write underneath. So multiplying by 3x gives me 3x cubed. Multiplying by 2 gives me 2x squared. Now I'm on the subtract step. When I subtract, the first column should cancel out if I divided correctly, and that will always happen in polynomial long division. When I subtract my second columns, 5x squared minus 2x squared is 3x squared. And just like in the last example, now I'm going to bring the next term down, which is the 8x. So now I'm back to the division step, and again, the division only involves the first terms. So we're thinking about 3x times what amount would give me 3x squared. It would take an x. That's positive, so I write that as a plus x up at the top. And now when I multiply, both the 3x and the 2 are going to get multiplied by that x. So that gives me 3x squared plus 2x, and then I subtract down my columns. Again, that first column should cancel out, and in my second column, when I subtract 8x minus 2x is 6x. And then bring down that plus 7, and now I'm back to dividing again. I'm dividing 6x by 3x because we do the first terms only. That gives me 2, which I write as a plus 2 at the top. And now I'm going to multiply the 2 by both the 3x and the 2. So that gives me 6x plus 4, and then I subtract. Now when I subtract, I have nothing left to bring down, so that 3 is the remainder. It's got a smaller degree than what I'm dividing by, and it has fewer terms. So normally for numbers, we would just stick that fraction at the end. For polynomials, I have to add that fraction on at the end. So that's plus 3 over 3x plus 2. If I didn't write that plus sign, in algebra it would look like the fraction was multiplying by the 2 instead of adding to it. And that's my answer. So just to recap what happened here, when we divided the 3,587 by 32, we got 112 and a remainder of 3/32. Now, if you compare those problems, do you see the 3, 5, 8, 7, and the 3, 2? They're actually the same problem, except instead of having a thousands place, a hundreds place, a tens place, and a ones place, we had an x cubed, an x squared, an x to the first, an x to the 0. So notice how similar our answers are also. That's a 1x squared plus a 1x plus 2 plus a remainder of 3 over 3x plus 2. So there's the 1, 1, 2, 3 over 32. They're basically the same problem. This is the end of page 2. Now you'll need to go to the next video for page 3.